Hello there. Thank you so much for joining this webinar today. My name's Alex Lawrence, the Managing Director at Telco Forge, and I'll be your guide to the hour ahead. Telco Forge was built from the fact that in many corners of the industry, you'll find people uneasy about how things in the telecoms industry maybe don't seem to be working quite the way they ought to. We love to talk to people who are finding new ways to build the telecoms industry into a sector that works better. And so I'm glad to be here today. The theme of our webinar is scaling 5G non-terrestrial networks, integrating satellite and terrestrial connectivity for ubiquitous coverage. Now, there are probably some cynics out there questioning the value of ubiquitous coverage because in many advanced economies, cellular coverage reaches over 90% of the population already. Now, that said, true ubiquity opens up some important opportunities. One of the early uses discussed for 5G was for ambulances. Now, early on in the 2010s, that wasn't terribly effective as 5G coverage wasn't everywhere and still isn't due to black spots and areas where the economics of adding coverage just don't stack up. That unreliability killed the use case, particularly for things like remote triage and so on, because better to kill the use case than risk the patient. Today, though, there are 5G-enabled ambulances out there which are able to maintain mission-critical communications between a hospital and ambulance staff for early triage, video conversations and treatment while en route to hospital. And that's because, as standard today, many of them switch between terrestrial and satellite systems at need. And what's more, it means that even in cases where the local network is down, for example, in natural disasters, the service still works. And that resilience is life-saving. Now, the non-terrestrial industry is in a ferment, as we all know, and the way that satellite services get delivered is changing fast. But what does that mean for telcos who want to engage in ways which might be less challenging than in the past? I'm here today with two experts in non-terrestrial 5G to work through the technical and commercial elements. Shravan Gadam is Vice President and Senior Fellow for Engineering at ST Engineering at iDirect. And Chinmoy Sabud is the Senior Director and Head of Business Development at Capgemini. We're going to have a conversation during this hour, so I'd encourage anyone in the audience who has a question or comment to write it in the chat as we go through. I have some things I'd like to set the scene with, but we'll have time dedicated at the end for audience Q&A. And if we run out of time before we run out of questions, then it means that we can follow up with you by email. So also coming to you by email for reference, a copy of the recording tomorrow. And the last piece of housekeeping is that there are helpful links and documents available for download in the resources tab. So do please make the most of those. Now, recently, iDirect and Capgemini signed a collaboration to develop a non-terrestrial 5G base station. And to kick off, I'd love to have Chinmoy and Shravan introduce themselves and then answer a simple question. You know, why are you collaborating and what can you deliver together that isn't already in the market? So Shravan, let me ask you first and then get Chinmoy's perspective.
Sure. Thank you. Thank you so much, Alex. And good morning and good afternoon, everyone. This is Shravan. I'm from iDirect, the CTO office, responsible for the 5G NTN and telco strategy, and of course, the partner ecosystem building across the 5G infrastructure and all the partners that I work with. So that's pretty much my role. And I come with more than 25 years of experience on the terrestrial side of it, been on the terrestrial network for quite some time and working on the NTN side for the last 5 to 6 years, predominantly focusing on the ground segment and of course focusing on the transparent and the regenerative architectures and working on the software side of it and the product development part of it. So on the collaboration, definitely, I think the way we have evolved in terms of what is needed from the market perspective and also the technological advancements and the specifications that are evolving, I think we felt the right partner or to collaborate with is a Capgemini, where we get the L2, L3 stacks from Capgemini, and we're building the whole ground system and also the I would say the module software components that's needed for the space segment also. So that's pretty much in a nutshell in terms of the what my role is and the collaboration that we are having with Capgemini. Over to you, Chinmoy. Maybe you could go ahead and then introduce yourself and then talk about this a little bit.
Yeah, thank you, Shravan and Alex. Warm welcome to everyone. Yeah, myself, Chinmoy Sabood. I'm based out of Washington, D.C., and I'm the Senior Director Business Development for Capgemini's very unique portfolio, software frameworks and solutions. And in fact, I still remember when I started straight from the college, my first project was around the satellite communications, building a NMS development for a satellite networks. And then a lot of journey through the 3GPP and different specifications. But it's really glad to see that again, the satellite world and the wireless world are converging. So, and I played multiple roles last 25 years, starting from writing code as an engineer to product line management and the sales and business development. And each one of us, even including all of you, whoever is part of this journey or contributing in whatever role, I think we are part of a great movement that communications industry, the way it shaped the world, the way it actually improved the lifestyle and the whole world since last couple of years. So now to answer the questions, Alex, on the merit or the crux of the collaboration. So essentially, if you really see Capgemini as an organization, so our theme is that we help our customers to imagine their future and we actually make it real. And within the Capgemini, actually, I'm part of a Capgemini Engineering, which is a global business line. And apart from collaborating with our customers in different innovative projects, we have a very unique portfolio of software solutions and stacks, and which essentially we proactively invest in those assets, we build, and then we actually use those assets to co-create with our customers. And there are many industry firsts around multiple 3G or 4G and 5G networks. So when this 5G world is moving towards the NTN, we are also building, as Shravan mentioned, that the 5G assets, which is adapted to the NTN. So we definitely see that I direct, and specifically we typically engage with the OEMs who are building the products. So it's a fantastic positioning alignment, technology alignment. And moreover, the best thing is that a proven solutions and the leadership alignment is one thing, but on ground also, both the organizations, starting from the engineering to leadership, all are actually sharing this vision and alignment. And on ground, we are working together to make it a success. And we see NTN as a great future. And it's the momentum, it's the next wave of, I would say, the technology momentum, which is gaining and moving towards the 60. So we see a lot of success in this collaboration.
Brilliant. Thanks very much, both of you. So just to kick things off, when we're talking about this integration of satellite and terrestrial connectivity, from that technology standpoint, what does it take to enable true seamless mobility and roaming across those satellite and terrestrial networks? Shravan, maybe I can get your take on that.
Sure, yeah. So maybe let me just go to the slide. Yeah, so I think the way we look at 5G NTN now, or what we looked at before, right? I mean, it was more about extension of coverage, where we could rely on that. But as of today, it's no more a coverage extension, right? I mean, it is more of a convergence of the architecture. And that is where what iDirect has been doing is building a platform, right? A convergence platform essentially built based on the cloud native principles. And that's what we're building for the Intuition. Intuition is a platform that we're building, which has a legacy, what we started from the satellite expertise and evolved that into a cloud native based architecture, which essentially means that all the functions that are software defined, right, and which enables all the dynamic scaling, where you could scale up and scale down, which is pretty much predominant in the telco side of it. So that's essentially what we are bringing into the SATCOM side of it, where we wanted to build this whole converged platform. So that is very, very essential in terms of the technical point of view, as how we would want to be ready for the advancements, and also how we would want to evolve the whole system. So that's one of the main, I would say, the critical point. Now, the other thing, because we're talking about seamless mobility and the roaming aspect, and we're talking about different access types, whether it's your DVB-S2X or the 5G NR waveforms. Now, what do we need so that we need to move across these different access types or access networks? That's where it leads to a hybrid UV solution. And I would say that iDirect has been working on the hybrid UV support, which would, I would say, support in the multiple waveforms, right, which would switch across our high efficiency S2X waveforms that we already have, and going forward into the standard 5G NR waveforms. So that's where, from the UV perspective, that is again one of the critical points that we need from the technology side of it, where it is needed from or enables the whole mobility part of it. Now, when I look at the architecture, if I go a little bit deeper, now of course there's a 5G core, which is going to unify everything else. Now, what we have in the 5G side of it is the 5G core, which enables, which acts as an anchor for the mobility part of it. So that is what we wanted to bring it into the NTN or the satellite side of it too. So where we would want to have a 5G core, which unifies both the non-3GPP access part of it, which is going to be your legacy terminals, what you have today. And then when we move towards the 5G NR waveforms, then once we have the terminals and the hybrid UV part of it, what I was mentioning a little earlier, all those things coming into the core infrastructure, which is where you're having the unified 5G core. So that is really essential, because the first thing is, how do I leverage the existing satellite terminals and have use cases so that they could use the 5G core, and then moving forward for the 5G NR waveform, and then eventually from the roaming perspective. So that, I would say, is another piece which, from the technology point of view, that we need to support. Then it goes into the operational maintenance. So having, again, this is something which you have seen in the telco side of it, where we had multiple access networks, where they start with 2G, 3G, 4G, and then LTE part of it. And then we have multiple components that exist in the network, but we still have one unified NMS. So that is where we would want to bring again across the SATCOM and the terrestrial side of it, where we would want to have a unified NMS, which will work across hybrid environments. Hybrid in terms of its terrestrial, or the 5G NTN, or even the non-3GPP NTN part of it. So that helps basically you delivering the operational oversight, even the intelligent bandwidth allocation. So which is one of our products that we have, which is called a global bandwidth management module, which is essentially uses, I could, if I were to draw an analogy for that, from the terrestrial side of it, what we have a RAN intelligent controller. So that is essentially what we would be employing as part of our global bandwidth management, which would take care of the bandwidth allocation based on the need and basis, and which will, of course, assure your quality of service. So it's a unified NMS, the 5G core part of it, and the hybrid UV, and then the architecture. Now, on top of all of these things, what actually everything gets together is being compliant to the standards. So I think everybody has been talking about it, and then I keep reiterating this point, because that is very, very essential when we want to go and build a network of networks. And that is where adhering to the standards is a must. And I would say it's a non-negotiable when we go into this ecosystem. And anything, as we all know, the release 17 and beyond is where the NTN started, and that is evolving and will continue to evolve. And that's where even iDirect contributes into the 3GPP specifications, and of course the TM forum and MEF part of it, where I think these are the standards which are essential for your business and operational processes, and using the standardized APIs, right? That would what make it as a very, very clear for us in terms of how we wanted to do the integration piece of it. So I think these are the main points, Alex, that we would need from the technology point of view to be in place so that it enables the seamless mobility.
Yeah, and that's good for you to say, but I do just looking at that, it is a complex process to integrate that NTN into 5G. And just last week, the NGMA actually published a white paper talking about cutting 5G complexity in a terrestrial standpoint. So clearly, complexity isn't popular with operators. So, Chinmoy, how do you simplify this?
Yeah, Alex. So it's a very good question. The simplification. So maybe where Shravan has given us a hint that standardization is the key. So if you really see to uh, make things simple, interoperable, I think standardizations is the way forward. And that's what exactly is happening in the market. So if you really see the 3GPP specifications, the way it is evolving, essentially the intent is to have the same mobile platform which can work with the satellite networks and the terrestrial networks. And to really have an integrated and ubiquitous coverage, so basically everyone has to follow the standards. And 3GPP and all the other standards are actually helping to move towards that direction. So one is following the standards, which will help to simplify, and another is also, I would say, from implementation perspective, the architectural choices you make. Because if you really see in the non-terrestrial network, the kind of use cases which are envisioned, so that actually asks for a lot of resiliency. Okay, so basically the merits of having this both the worlds together goes with the resilient network, a continuous service, ubiquitous coverage, and then also the scaling up and scaling down of the networks. So in those aspects, the kind of architectural choices we make in implementation, that also matters a lot. For example, uh, specifically, if you really see the intuition, the platform itself, which is cloud native by design. And if you really see the 5G software which we are building, it is so essential to have a cloud native architecture. And there are merits because in the cloud native architecture, when you move towards this kind of an architecture, it automatically solves a lot of problems and simplify your life in terms of the automation, in terms of the elasticity, in terms of the high availability, in terms of the service creations, or even if you want to create a network slice, it's much easier to implement those aspects in the cloud native architecture. And similarly, if you want to add more functionalities, for example, today also the Intuition platform supports the multi-orbit in the context of a satellite network. So if those are the features or those are the add-ons, if you want to add, it's much easier to actually implement those in the cloud native architecture. So standardizations, the architectural choices, and another aspects I would say that more and more we move towards the 6G, the AI native or the usage of AI is also an essential part. That how actually we make the AI also integral part of my platform to make some different choices that would also be very much needed.
Great, thanks. And you've mentioned some of the use case that people might want to apply here. So how should the telcos think about going to market when they're introducing these hybrid terrestrial and satellite services, do you think? Is there are we going to be looking at everything coming in from day one? Or are we looking at something that goes in stages?
Yeah, so basically, before moving to the use cases, let's say, Alex, another thing we need to also understand that to simplify the things, the standardizations are important, but to also realize the different use cases, the innovation is also equally important. Because in many of the cases, we have seen that the specifications are a little open. For example, if you really see that the bandwidth management, what Shravan was talking about, right? So really in the satellite world, that how you actually manage the beams and how you actually manage or handle the dynamic demands, etc. So in those areas, specs are not very much, I would say that the prescriptive, right? So they kept it open. So there are a lot of areas where a lot of innovations are required to really create a fantastic user experience or quality of experience for the consumers. So to touch upon few areas, for example, one is obviously beyond the specifications, we need to also have to have a very open interface. For example, how easy it is to really kind of in today's satellite world to integrate with the satellite control center, right? So how you actually define those interfaces, the flexibility and openness in the interface to integrate with the legacy systems. That is also how you are thinking. That is also important. Similarly, the innovations around this one area, for example, the BIM management, typically from Capgemini side, apart from building the standardized blocks, we are also actively researching on the areas that how we actually can create a innovative beam hopping algorithms, which is kind of adaptive resource management based on the criteria of the dynamic demands coming in different sales, plus also maintaining the 3GPP constraints, because there are constraints, the scheduling and timing constraints, which you also need to continuously maintain. So this is a research area. Similarly, in the vision of the integrations of the terrestrial network and non-terrestrial network, there are a lot of areas where I would say the AI-based algorithms are getting introduced. For example, the intelligent handovers, or how you actually and when you make the handovers, right? So even in the specifications that they call about the conditional handover, which is not really to reduce the number of protocol messages to simplify the things, but essentially the conditional handover is more like a location based or time based, which is very much needed in the satellite scenarios. But even to make those choices, right, so there has to have some kind of an intelligent handover decisions between the two cooperating networks. And that's where the lot of AI models and other things can be very, very beneficial to make those intelligent handover decisions. So that's an area where innovation is needed beyond the standards. So these are the some of the things where Capgemini is additionally working beyond making the 5G NTN solutions, which are multi-orbit, D2D, NB-IoT, all the flavors. So beyond that, also we are also actively engaging on the core side, the NWDAF side, and the AI based and the beam hopping algorithm. So there are a lot of add-ons which are research based and innovative based. And how it actually helps to seize the use cases. Now coming back to the use cases, so if you really see the way the 3GPP technical reports have envisioned the use cases for the satellite access for the 5G systems. So they have defined it very, very nicely. They call it, one option is obviously the service continuity. So for example, you are in a 5G terrestrial networks, but you move to a place where there is no terrestrial coverage, but you still want to continue to have the similar services where the coverage is not there and continue the services. This is typically, for example, the asset tracking or the automotive industries, right? So you are going into the geographical area where there are no coverage for some time, and again you get back to the coverage of another terrestrial network. So that service has to continue. And this is one. And second set of use cases which 3GPP technical reports talk about is the service ubiquity. So basically, let's say for economic reasons or for geographical challenges or terrain challenges, you don't have the 5G terrestrial network in some of the areas, or even if you have the 5G terrestrial network, because of the disasters or other things, your network was down. But you have to create an alternative network immediately to cover those areas and to give the services. And in those cases, even the network slicing also becomes very important, because when in the disaster kind of a situation or disaster recovery situations, there will be different needs for the public safety officers or maybe the enterprises or the typical consumer. So you have to not only create the satellite network coverage as a resilient another layer, but you have to also create a different network slices to really give the different and the user needs in those slices. And the third is obviously about the third topic is more like a service elasticity, or I would say the scaling. So essentially, even if you have a terrestrial networks, but because of some reasons, because of events, or because of some streaming or some content expectations, right? So you need to scale your terrestrial networks and for certain temporal basis or for certain timelines. So instead of really expanding your infrastructure, which is costly, in those cases, it is much more meaningful that you create and take help of the NTN network to really address those demand gaps. Okay, and obviously on the content side also, There could be a lot of because of the NTN network has a huge coverage, lot of multicast broadcast kind of a content scenarios and time basis scenarios. You have a very cooperative arrangement between the terrestrial network and the non-terrestrial network. So these are the three different use cases, I would say, which is from the definition perspective. But if you break it up into a different ways, that okay, from consumer perspective, the service continuity and mobile connectivity in areas where there is no coverage, that will continue. And then there are business to business for enterprises, or let's say offshore oil rigs, or wind uh, turbines and those wind power generators, which are in a very different geographical terrain, but it wants to connect with the central office. So those are the areas at the best. I would say those are the automotive. So there are different critical enterprise sectors, the utilities, the automotive. Those are the enterprises which will make use of the NTN services.
Great, thanks, Chinmay. Now, Shravan, I was just looking at this picture here, and while it's absolutely important, I know we've talked a few times about the roaming question, and in particular the hybrid roaming, which seems to be a key differentiator in all of this. The thing is, a bit like AI, it seems to be a term that can be applied in a few different ways. So just for the sake of clarity, can you talk us through some of those different hybrid roaming models and what they might signify?
Sure, Alex. Yeah. So I think leveraging all the enhancements and the innovations is what Chinmay and myself were talking about, right? I think the right architecture to be there, and in terms of the AI and intelligent handovers and everything else. So essentially, utilizing the infrastructure and the innovations that we would be building as part of our ground segment and the space solutions. And as I was mentioning about the bandwidth management based on what is the coverage and where is the access part of it. So that is where the roaming comes into picture. And the different types of roaming, I mean, the way we are trying to, I would say, target or capture this is what is there today and where do we want to go eventually, right? So I think what we have today is a legacy satellite networks. How could the existing satellite operators leverage the investment that they have made today, and where do they and how can they reach to the final end goal, right? The final end goal is definitely where we would want to go to the 5G and our NTN with seamless roaming across all the networks, but we cannot go there on day one. So what we would want to do is as a sequential in terms of realization, I would say sequential, but not in terms of developing the product, because that is something which has to be done in parallel anyways. So to start with, what we have is a legacy networks. What could they do with that, right? Leverage the services what they have today is one thing which I already talked about, which is a non-3GPP NTN based access. Now, what is the logical next step after that? Which essentially means now there's one non-3GPP access network and there's one more non-3GPP access network. Now, can the users of the terminals move across that, right? So that is where our first roaming model which would come, which is between the non-3GPP or S2X and MRC networks. That's the roaming part we're talking about it, right? So what does it mean from in the vendor's perspective, from the user perspective, and from the operator's perspective? Now that is actually going to unlock new revenue opportunities from the operators, where you're saying there's no coverage part of it. Again, I'm talking about only the non-3GPP aspect, right? It's not even not gone to the 5G yet. So what we can do today, access to non-3GPP, and then go into the roaming between those two, I would say, non-3GPP networks across different providers. So that is the first roaming, or the hybrid roaming is what I would say. The second thing is, while we build the 5G NTN part of it, right? Then the second logical step is have those two networks, 5G NTN network and the existing non-3GPP network, and then have the users roam across that. So that would be the second hybrid roaming, or at least the roaming aspect of it, where we would want to move users across 5G NTN and the TN. Now, that is where if I have to move across the different access types, then the need comes for the hybrid model, right? And that is essentially where the hybrid modem and the hybrid UV part of it development is what we have to do it in parallel. So that's what I said. It's not a sequential thing. While we're working on the non-3GPP part of it, there is a need for the hybrid UV coming up as a next step. So that work is already in, I would say, we're building all those things, which would be leveraging the second roaming part. Now, eventually, where you would want to do is the network of networks, which I've mentioned before, is having access to all different types of network types or access types. That's where we're going roaming across your 5G NTN and the terrestrial network part of it. So that's the eventual goal, where we have a hybrid UV still. The users could roam across non-3GPP to 3GPP, 3GPP to the terrestrial network. So that is a third type of roaming which we would enable as part of this journey. So it is, as I said, it's a sequential, but it's with time that's going to move. Now, this is what I'm talking about only in terms of the roaming aspect of it and the capabilities of the UEs, but definitely there's a network aspect of it, what we're showing over here as how and what are the different types of multi-orbits and where your baseband processing and what where these network processing clusters could reside. Now, that is a different subject in terms of the architectures, right? As I was mentioning in the beginning, in terms of the transparent and the regenerative and how you want to split them, whether it's a partial regenerative with the CU-DU split. And that is where it goes back to the disaggregated architecture piece of it, which the ORAN has defined and which definitely we are getting into, I would say, which pretty much plays an active role when we're trying to split these functionalities as part of the architecture. So overall, I'm just stressing on the point that architecture is essential, compliant to the standards, and definitely the hybrid modem, I would say the strategy where a user could move across different access types. All of these things should be coming into the picture. As I show you in this diagram on the right-hand side, if you see the different types of UVs, which are connecting into the transparent SDS or NGSOs, and then how they, reflect into the network side of it and how exactly it comes in. Just for the color coordination perspective, if you see the green ones are the legacy ones and the blue is where you're saying the 5G NR and how it's going to come into the network and how exactly this roaming will be possible on the network side of it. Now, there are multiple aspects. I see there's the 5G core and the UPF and the AGF part, which is mainly from the satellite interworking gateway, which would give an access to the non-3GPP network elements. And that is what iDirect has built, a satellite interworking gateway, which would give access to the non-3GPP part of it, which would form again an essential component along with AGF from the roaming part between the non-3GPP networks. Now, when it comes to the 3GPP and the non-3GPP, that's where your 5G core, the UPF, and also the functionalities that we're building as part of the G-Node B and all the other network elements that would come into effect. So at a high level, just to summarize, the three basic roamings, what we would be going after is roaming between different providers for non-3GPP. Then we have non-3GPP and the 3GPP roaming. And finally, it's the terrestrial networks and the non-terrestrial networks.
Great, thanks. And alongside that evolution, you've mentioned the UE several times, and for a lot of potential customers on the ground, that's going to be one of the key questions, I should think. So, can you expand a bit more on some of this UE evolution that you see?
Sure. Yeah. So as I was mentioning, I think from the hybrid roaming and the seamless mobility aspect, since we are talking about the different access types, that is where the need comes for the hybrid UE, right? And that is where iDirect has been working, I would say, for quite some time in terms of building the 5G UEs, right? Which I would say the hybrid 5G UE supporting the multi-waveform and of course the multi-provider roaming, which I was just mentioning, and the multi-orbit technologies part of it. So what we're trying to do is, we want to leverage the 5G chipset ecosystems, right? Try to get that and then build a hybrid one which supports both the S2X waveform and the 5G NR waveform. There was a recent, in fact, the PR from iDirect where we have built a software-defined modem. It's a 450 that we have actually concluded successful live over-the-air point-to-point testing of a DPB-S2X waveform where we have used a virtualized waveform core, right? So that is something which we have, the recent development. It's maybe 2 or 3 days back, we did issue a PR and I would say the report on that. So that is one thing on the 5G ecosystem part of it from the waveform and the chipset. Now, the other thing which I want to highlight as part of how we've been evolving our UV story and the fact that we have actually been, I think this also was, there was a PR in terms of where iDirect's UE chipset has been selected for the Airbus Up Next program, along with different partners with trying to build up the whole end-to-end 5G demonstrator environment. And iDirect is actually providing the chipset for the 5G and the hybrid part of it. So again, it's not something which is going to happen on overnight or in a few weeks. It is a journey, and where we have I would say an incremental roadmap for that, where we're trying to get the first with the of course working with the chipset ecosystems and building the software modems on top of it. And the idea is to evolve this thing as part of 2026 is where we would have an aviation POC. As part of Airbus Up Next program, where we would be taking our chipset over there. So, long story short, I would say it's a tremendous strategy, and it's a very compelling thing from the market perspective, where this networks is going to evolve, having multiple access network types, and that is where we are focusing on the building of this hybrid 5G UVs.
Great, thank you. And so, just for you in the audience, for your reference, I see that there are several questions that have come in already, so we will get to those shortly. But before we kick off into those, I do have one more question that I'd like to put to you both, and this is kind of acting as a bit of devil's advocate here. So many operators take a wait and see view to technology adoption, and letting a few brave souls get the early experience and then jumping in later when it feels a bit safer. In your view, is there a counter argument to that? What would be the key advantages for a telco to adopt something like this hybrid roaming early? I'll let either of you jump in there, but I mean, maybe Chinmoy. Yeah.
Yeah, sure, Alex. So if you really see this particular NTN is like a wave, okay? The release 17, 18, 19, and there are more work items which are getting developed under the 3GPP. So this is going to happen. So now the point is when the telco and satellite world will converge in terms of the use cases, in terms of the agreement, in terms of the partnerships. Already some of the partnerships are already started to happen. But the vision of 6G or moving forwards, even starting with the non-terrestrial coverage or the satellite coverage, the way the future is looking like, it's like a ubiquitous coverage, and there are satellite networks and the terrestrial networks are working in tandem. And they are actually not into a competition, rather they are into a cooperation, because that's the vision. And where I think I must appreciate the iDirect's vision as well. So basically, we have currently a world of RDVVS2X, a satellite world, right? Now, moving from this satellite world to a completely the 5G world, we have to go on a step-by-step basis. So this inter-provider roaming is essentially to utilize the current satellite networks, maybe between them, to really utilize or getting mutually benefited from each other, so that we get a broader coverage. We actually monetize the whatever network build out already happened. Now from that, the satellite world will get converged with the 3GPP world, or which is essentially, if you really see the non-3GPP access and the 3GPP access, if we combine these two things, then essentially we need to innovate on the UE side, because you need a hybrid modem which can actually realize and can be present in both the networks, and user gets the flexibility of roaming between the two worlds and access to both the worlds. And here also the satellite operators and the telcos can cooperate to really enhance their reach in terms of the coverage, and users also gets benefited because they gets the beauty of both the worlds. Yeah. Now, moving forward, if I really see that there are a lot of satellite operators in different orbits. Let's say some of the geo operators, some of the LEO operators, and there are different spectrum holders in the satellite world and the terrestrial world. So the vision is that ultimately all the satellite operators and the telcos should work in tandem. It's like I would say, the extended and the overall coverage of the Earth, right? And that's where the specifications are also evolving. So if you really see the study items of the next release 20, etc., that how we can enable the multi-orbit connectivity, or continuations or service continuity in multi-orbit scenarios, how we can actually do the connected mode handovers between the LTE and the 5G NTN. So all these problems, while the specifications are solving, with a vision that end of the day it will be a unified world. The satellite operators and telcos will be working in tandem, in cooperation, and not in competition. Now, which use cases we should focus really that to go after, that which will give them success, or maybe the ROI, or maybe the benefits? My take personal view is that, because when I see my kids, right, so they don't really believe that, okay, there was a once upon a time, there was a world where there was no internet, no mobile phones. They say, how can it be possible? Are you serious, daddy? Are you really saying that there was no mobile phone and no tablets and no internet? So this is the consumer behavior or consumer habits. So basically, if there is a power outage, if there is a no connections while he's in travel or he is traveling, so the next generations, they always need to have a need, I would say societal need, or it's ingrained into their DNA that they need a connectivity. So I would say that extending the coverage and giving all the consumers the choice that, okay, at least there is an option that they can connect to the internet, connect and get the services. That is very important from consumers' mindset perspective. That will give the returns, even if you start with a choice to the consumers. Then definitely the disaster recovery, and that has a different needs from government and other perspective, that we need to really have a disaster recovery, some resilience in the network, which is needed. And for that also, this both the world should converge. And then there are enterprises which are definitely even there are use cases where people are thinking that even a decision making in a split of seconds are so crucial in the financial world. So there are certain transactions which are high frequency transactions, or some decisions, even if you save a little bit of delay or latency, you actually your decisions are so crucial, time sensitive. So even people are thinking that, okay, the whole network, the enterprise connectivity through satellites, and enabling this highly prioritized transactions, saving some timing going through the fiber and going through the air, that you can save some times. Even those are the use cases probably in future we'll see. But immediately, I think extending the coverage should be the first point. And in the telco world, the provider cooperations through roaming is important. And satellite world to the telco world convergence, the UE side innovations is very important. And also going forward, I think there are certain topics where 3GPP is also deliberating on concepts like we have seen that in the non-3GPP and 3GPP world, the concepts like ATSSS. So similarly, there are certain concepts of dual steering, so that you really create two paths to a satellite uh, uh, slice and the terrestrial slice. And then the user gets a unified experience and the coverage, and there is no failure. So those are the things will also evolve over a period of time. But I think extending the coverage will be the first step for telco to pick up.
Right. Now, I think just to add on that, Alex, and then I think the question was mainly, I mean, if you want to address that, why should telcos adopt, this early hybrid roaming or hybrid networks, right? I think it's pretty obvious. I think just to hit the main points, right? I think one is from the network perspective, right? I think to build I would say, it's more reliable, and the resilience part of it, which you always talk about it, and the network resiliency, where you want to avoid single point of failure, you want to have path diversity part of it. So that is essentially one of the main things, what I would say, where you have a hybrid roaming or hybrid access part of it, where provides the service continuity, and what you reduce the risks of a single point of failure, as I mentioned, right? And again, at a very high level, if I would want to talk as why they should adopt early, is that is where you try to get into the market and then see where you could expand it, right? And then what are the other areas of revenue generation, identifying the use cases. If you wait and then for longer time, then you're actually missing the bus, and then you don't know what use case you're going after. So that is where I think getting into those discussions with the other members in the ecosystem, whether it is satellite operators or the vendors like us, all of us get together and then talk about the use cases where you could come out, brainstorm, and then see where the revenue generation opportunities are in the market. So I think this is where I feel I think technology and architecture, we talked about it, but in terms of the business side of it, I think the sooner all the parties and especially the telcos, right? I think they start adopting this. I think that would be better because that is where we try to identify what are the I would say the ready use cases that we could go after. And of course, there are other things that there are advantages that we talked about in terms of cost efficiency, leverage the networks which are already there and then don't have to build everything from scratch. And there's a lot of comparison that has been done with respect to building the towers and laying the cables all the way the fiber part of it in the remote areas versus leveraging the satellite networks. That is where the flexibility and the cost efficiency part of it, right? I mean, these are I would say, pretty obvious but very hard-hitting points where I think the telcos should start adopting this at a very very early stages rather than wait and watch kind of a thing. And of course, it's going to be a baseline or at least a springboard in terms of the emerging technologies with respect to 6G once we're going forward of it, right? I think these are the things. I mean, even if I had to tail it down, resilience, the revenue generation and the market expansion part of it, which is very critical, work with the ecosystem and see what we could leverage, and then lay the path for the future in terms of the technology evolution, whether it's 6G or whether it is AI and everything else, because everything is what we're talking. I mean, we always used to think that, okay, AI is going to take some time, but with no point, we see that how it's coming into the telco side of it and how we're using the AI in every aspect of it, whether it is the infrastructure, whether it is the services, whether it is your network equipment, everything what we're trying to do revolves around that. So in no matter, I would say within no time, the other technologies will come up, and all these things is what we're saying we should be able to work together. And that's where I think it's critical and important for telcos to adopt this thing sooner than later. I mean, because it helps the overall growth and also in terms of the resilience and I would say the reliability part of it.
Brilliant, thank you. That's really useful. Just coming on to some of these questions here. Some of them are quite specific, but really quite interesting as well. One of them we've had in is asking about the spectral efficiency that we can expect with the 5G new radio waveform and how it compares to today's predominant SATCOM waveforms. And I don't know, that sounds like that's maybe one for you in the first place, Shravan?
Yeah, so I think from the spectral efficiency and the latency part of it and the technical aspects, yes. I think the way we compare with what is happening today from the 5G waveforms and compared to SATCOM, definitely I think SATCOM waveforms are more evolved and more efficient. That is, I don't think I don't think there's a denial in that. But definitely there's a lot of work that needs to be done in terms of the 5G waveforms, whether it is any enhancements that we want to do it in terms of the spectral efficiency or the latency and all the other technical aspects. I mean, I would say with time, at least that is where a lot of work that we from iDirect we are trying to do and trying to do a lot of enhancements as what we would want to do with getting our satellite expertise for the last 25 years, whether we would want to get into our schedulers and everything else. And that's where I would say our focus from the differentiators perspective. Now, I do not have any, or at least I don't want to say any specific numbers as a reference over here yet. I think that would be coming out based on what our feature testing and all the other activities that we will be doing it. But on the nutshell, what I could say, is it better than the SATCOM yet, the 5G waveform perspective? I think it would take some time, but it is something which we have to work towards. That's what I would say.
Great, thanks. And I'll throw one at you now, Chinmoy, as well. We've had one come in here, which is asking about particularly the hybrid roaming situation. What use cases are most likely to see early success? Now, I wonder if that's just going to be an extension of what we're currently seeing, but yeah, any thoughts on that would be great to share.
Yeah, as we discussed, so I think in case of hybrid roaming or the cooperation between the satellite network and the terrestrial networks, I think the automotive industry, the infotainment everywhere, or even tracking and navigating, and even if you are while you are driving, I think the connected vehicle, the automotive industry is a very good use cases to cater to. Similarly, the utilities, and obviously from the mission critical perspective, also the public safety and defense. So these are the critical utility sectors or enterprises around the critical utilities, which are in a little bit different geographical regions. The smart automotive, and then the public safety and defense from government perspective or mission critical use case perspective. I think those are the use cases which will are definitely needed, this TN and TN cooperations and the roaming between both the networks. And another is obviously associated with the automotive is the logistics and tracking perspective also, the asset tracking globally in any region. So those are the another industry where we clearly see possible cooperations between the NTN and TN world.
Brilliant, thank you. I'll throw this one over to both of you, but there is a question here as well. I think you both mentioned 3GPP standards, understandably, and at the moment we're a long way from having those complete. You know, we're looking at sort of proper integrations over in 6G, but how do you see those 3GPP standards evolve to support that hybrid roaming? Or, I mean, do you think that's actually going to be necessary by that stage?
Yeah, Alex. So so if you really see the standardizations effort, so definitely the specifications are evolving to address all different scenarios of roaming. And essentially already in the specifications, there are a couple of approaches, the handover mechanisms, the roaming mechanisms, defining the satellite network as a different RAT type or satellite access types. So there are in the specifications already the different handovers and roaming mechanisms are in place. There are also the network driven. We also see there are specifications around the NWDAF or network data analytics functions where different roaming exchange entities are defined so that you can have more intelligent handover and roaming decisions, data exchanges between the cooperating networks. So standards are evolving, and I think there are many things are already in place. Yes, there are a couple of things. Obviously, the release 20, if you really see the agenda points of multi-orbit connectivity, even within the NTN networks, if you have a different orbital satellite networks, and how do you actually interwork and cooperate among those networks. So the multi-orbit connectivity is an area where we will see the specs are getting matured. Similarly, the connected mode in service, while you are transitioning from a NTN network to a LT network and others, those are the another areas where specs are evolving. The study groups are working on that. So we see more and more such definitions coming in the specification. So eventually to realize the 6G NTN vision that everything is connected, even the space networks, the ground networks, it's like a 3D infrastructure giving you the full coverage as long as both the worlds, the satellite operators and telcos are cooperating with each other. But technologically, yes, this is feasible. There are small areas where still there are certain works are getting done, but I think eventually in next release or release 20 or the future releases, those things will also get addressed.
Yeah. Great. And there's one here that might be more along your more up your tree, Shravan, but feel free to jump in as well, Chinmoy, if it seems appropriate. But as we're looking at this much more integrated terrestrial and non-terrestrial network ecosystem, particularly around 5G, what should operators be looking for in terms of their partners for that technology and the integration to avoid lock-in and enable flexibility? I mean, is there a risk that we're going to end up in a situation a bit like we've seen in terrestrial networks, where there's maybe just a few leading partners?
Yeah. No, I think we did address some of the points already in this one, right? I think I'll go back to the first point is compliance to the standards. I think that is something which operators should look for in the partner ecosystem or the vendor ecosystem that they're trying to select or they're trying to look at. Again, not to repeat myself, but definitely all the specifications that what Chinmoy has mentioned about, compliant to the 3GPP specifications and disaggregated architecture part of it, which would actually pave the path for the architecture evolution. That is definitely, it's a most critical thing, and that is definitely the operator should look for. The other thing, what I would say is, in terms of how I would say the components are being built, which is essentially being the software defined, which again goes back to the point what I was mentioning about whether it's being a cloud native and flexible infrastructure, right? And then where we build the software defined ground stations, right? I think that is something which, in my mind, the operators should look for in terms of what they're looking at the vendors. Then, since it's avoiding the vendor lock-in, then it comes the interoperability. Now, maybe if I'm an operator, the way I look at it is, okay, what all, one is building your components or the products, but then where you have been interoperability tests have been done, or whether it, I mean, there are a lot of, I would say, the organizations and the test bodies, right? Whether it's a Plug Fest or whether it's any of the 5G challenge programs, or even if you look at the OTIC centers, which is the Open Test and Integration Centers. I mean, essentially where you have actually taken your components and worked with the other third-party elements, that would be more of a, I would, again, for the certification perspective or, your testing aspects as where you're tested with other than on your own components. So that is something which in my mind is very critical. And of course, the technical capabilities, but no, all the features are there. I mean, the things have been defined in the 3GPP, or you come up with your requirements or specifications in terms of what the customers are asking. But then where does an individual vendor or the partner's expertise lie? For example, I go back to what standards are saying, but then how many of these vendors or how many of these players are trying to do things well in advance, or trying to understand what the specifications are saying and build your expertise. I mean, I'm going back to the same point where I talk about regenerative payload. Right now, what is the expertise that each of these partners have? It so that is something which I would say the operator should look at before looking at or selecting those particular vendors, as what is the expertise, where we know that transparent is simpler relative to what regenerative is. Now everything regenerative going onboard processing, whether you want to split those things, which is a partial regenerative, what is the level of expertise that these vendors are having it, and that is one of the factors which, in my mind, that they need to look at when they're trying to look at the ecosystem. It's again, when I'm talking about the partial regenerative, because there are multiple players. There are hardware players, the software players, and even the CUDU kind of a split, which we're talking about across the ground segment and the space segment. So that also matters, and that's the compatibility and the interoperability that matters over there, and that is critical where operators should look at, okay, what is the expertise they have and what is the level of, again, I'm saying I'm not even going for testing there because it's more expertise in terms of understanding the architecture and the specifications, and that really adds value on top of it, right? So that is where I direct, what we are trying to do is providing a thought leadership. Again, I don't want to use, just for the sake of it, but in terms of the thought leadership where we are trying to work and putting all the solutions in terms of what we would want to do in the architecture point of view, and helping and engaging with customers as how we wanted to build the solutions around that. So I would say these are the main points which, as an operator, they should look into it in terms of when they're looking at the different vendors, to avoid lock-in, which we have seen, Alex, in the terrestrial, where we have a vendor lock-in and then there's certain things that it's difficult to come out of it. But with all the disaggregated architecture, where we know for sure that it's easy for folks to take one network element out and put it back in, as long as they are compliant with the specifications and have a architecture which is software defined, I think that would make very, very easy for the operators.
Great, thank you. Now, I'm aware that we're coming up to time. We've got some questions still from Rachel, Gara, Aparal, David, and Michelle, and others. So, please be aware that we'll try and follow up by email after this. In the last few seconds, there is quite an interesting one, though. So I'd like to ask each of you to just give me a one-sentence answer, if you can, and that's, what's the realistic timeline for a mass market adoption of this in terms of enterprise uses or direct to device? Chinmoy, maybe we can start with you there.
Yeah, so I see that definitely late 2026 and early 2027 will be the success timeline for the mass market adoption. And definitely, I think, as Shravan also mentioned, right? So the right architecture, cloud native, standardized software, that is one thing. But in addition to that, the platforms or the solutions which are expandable to cater to the newer features much easily, we have to be ready so that with the mass market adoptions and the other need of the specifications and standardizations, we are always ready to adapt and make it compliant.
Great, thanks. And Shravan, your thoughts on that?
Yeah, just to add, I think my point of view, I guess it's aligned with that. But the way I see is 2026 is the year where I would say all the ecosystem partners, whether it's SATCOM operators or the vendors, everybody is working to showcase. I would say it's more about the proof of concept, the demos, and then proving, saying that the technology is real. And 2027 is where it's going to, it's mass market, and then where will be the actual deployments and launching of satellites. So that's what I would say. All these solutions will become reality in 27. 26 is point where everybody get together and make it work.
Brilliant, thanks. And with that, we're pretty much up to time. So if you're watching this and you have further questions or you want to follow up with any of the speakers, then please do get in touch. Telco Forge, iDirect, and Capgemini will all be at MWC next month. So please do look us up there if you're coming past. For now, though, I'd like to thank Chinmoy and Shravan for their time. I'd like to thank you in the audience for your attention. And until next time, goodbye.
Thank you. Thank you, everyone.
Thank you. Thank you, everyone.